what happens with the original y equals x squared if we change some of the parameters. So if you guys remember from the previous lesson, we started with y equals x squared. So if I'm going to add here y equals x squared, so basically just looking at this. So you see that it's exactly the same thing as what we've seen before, which is, I'm going to remove the a as well, which is the parabola that's at the vertex that's symmetrical around the y-axis. Now, what we're going to look at what happens if it's not just simply y equals x squared. So y equals x squared, we call that the parent function of all quadratics. So this is where all the other quadratic functions originate from. Now, as you can see, now my equation is not equal to y equals x squared only. It's y equals a x minus h squared plus k. And these a, h, and k have values. So we see it here. I will include this in your lesson so you can do the same thing, so you can try it. So as you can see here, what I did first is I set up h and k to be 0. So basically h and k are 0, right? Which means I only have the following. So I only have y equal ax squared. So that's the same thing. If h and k are 0, right? So I don't include them. So I'll only have y equals ax squared. And then I'm going to look at what happens when I change the a value from 1, which is y equals x squared has a value of 1, to other values other than 1. So let's see what's happening to my graph. So if I take the a, and now it's a 1, and I'm going to increase it. So I'm going to go higher. So I'm going to go 1.11. What do you see? What's happening to that graph? By looking at it like this, what do you see happening to the graph? So the bigger the a value, what do you see? We see that the graph is getting narrower, or we call that it's getting skinnier, right? So it's getting narrower or skinnier as a is getting bigger. So I'm going to show you again, starting with a equals 0. I didn't mean to go that far. So a equals 1. We are going to increase a value, and then we see that it is getting narrower and getting taller. Now going back to a equals 0, a equal 1, sorry, I apologize, a cannot equal to 0. Now, if I go somewhere below 1, so I'm going to go values between 0 and 1. So not quite going to the negative, I'm just going into values between 0 and 1. So what do you see right now happening to the graph? It's not getting narrower anymore. It is getting wider. So you see that as a goes between 0 and 1, if a is between 0 and 1, we see the graph to be a wider graph. Now, what happens if I go to the negative? Obviously, a cannot be 0 because then I won't have a quadratic, right? At 0, it will just, there won't be a quadratic function. So what happens if I go to the negative? So as you can see, I'm going to start from -1. And then this is basically if I go y equals x squared and y equals -x squared, we see that, so I'm just going to graph y equals x squared. It's going to be in blue. So y equals x squared and y equals -x squared, you see them that they are the reflection of each other across the x-axis. So as I go deeper into the negative, we see that still reflected, and I have that skinnier graph, right? So you see that there is a skinnier graph, but going in the negative direction. Now, if I have, so I'm just gonna graph y equals negative x squared here. And then I'm gonna show you what happens if my a is, so we said if a is getting more into the negative, so -4, -5, we see skinnier. And then if I have anything between -0 and -1, we see that the graph is getting wider. Still reflected, but getting wider. So what can we conclude with respect to A? What can you tell me? What happens once I change A to a positive value that's greater than 1, a positive value between 0 and 1, a negative value between 0 and 1, and a negative value that's less than -1. So what you can do here, you can try first of all the negative, right? So negative x squared, and then I can try, or actually I just do that as 1, and that will be the x squared, okay? Now let's try values other than 1. Let's try 2. Let's try y equals 3x squared. So you see that the blue one is 2x squared, the green one is 3x squared. So you see that as the a value gets bigger and bigger, the narrower the graph is. Y equals 5x squared. So what makes something narrower? What makes, if you're going to take that graph and then you're going to do something to it to make it narrower, what do you do? Vertically. Remember that we're talking vertically here. To make something narrower, you're going to have to vertically stretch it, right? So think about an elastic band. If you have an elastic and then you want to make it narrower, you're going to make it skinnier, you're going to have to vertically stretch it up. So that's what's happening. As A is getting bigger and bigger, the graph is being vertically stretched. Now, if A is between 0 and 1, so let's say it's 0.5, that's between 0 and 1, we see that the graph is getting wider. So you can pick any value between 0 and 1, and then you're going to see that the graph is going to be wider and wider. And we call that a vertical compression. So this is when you're compressing the graph, when you're pressing on it to become wider. Now the same thing happens with a negative, but remember that with a negative, we're going to have what we call a reflection. So it's going to flip through the x-axis. So you see that if I have a as -1, right, we're going to have that flip in the x-axis. And same thing is going to happen with the -2. So it's going to be narrower, so you're going to have a vertical stretch. But along with a vertical stretch, you're going to have a reflection. So when you're stating this, you're going to say it's a reflection in the x-axis and a vertical stretch. It's a reflection in the x-axis and a vertical stretch. So that negative just makes it a reflection. And then depending on the value of the a, if it's 2, then it's a vertical stretch. If it's less than 1, it's between 0 and 1, then it's a vertical compression. So you see that it's -0.5, so it's a reflection and a vertical compression, right? So try these things out and see if, always compare to y equals x squared. So you're always going to compare to y equals x squared, see what's happening to your graph with that. Okay, so in this video we only did the a value, we only saw the how the a value is changing your parent function or your parent